This image shows the hardware configuration of the alarm system for Module 8 Lab. The main components are the NI MyDAC, shown here in the background, PIR sensor, and I also used a voltage regulator to step the voltage from the NI MyDAC down from 15 volts down to 12 volts, although that is not necessary. So the basic layout is the NI MyDAC in this box is connected through its USB port to the Windows computer. The 15 volt output, shown here, goes to my breadboard, where an LM317 voltage regulator, and these resistors are used to step the voltage down from 15 volts to 12 volts. 12 volts then powers the PIR sensor, which is shown here, and the PIR sensor output, which is this black wire right here. This black wire right here goes to digital input 0. I am also installed a 10 kilo ohm resistor. It's being used as a pull-up resistor from the 5 volt digital output to that same digital input 0. The pull-up resistor pulls that input high to 5 volts whenever there's no output from the sensor, and then whenever the sensor detects that there is movement, then the output is tied low. That's to help prevent if there's any noise on that line, which could be detected as movement. That helps eliminate that. The screen shows the graphical user interface for the Module 8 alarm system. This alarm sound frequency input allows the user to set the frequency that is played over the speakers when the alarm is triggered. This LED indicator indicates whenever the alarm is triggered. It is green whenever the alarm is on, and it is black whenever the alarm is not on. The stop button simply just turns the alarm off. This image shows the LabVIEW VI for the Module 8 alarm. Once run is selected in the GUI, time delay VI counts down 30 seconds, which then enables the while loop. To the left of the while loop, simulate signal is used to generate the audio tone that will be played whenever the alarm is triggered. The user has the option of changing the frequency on the GUI, and the output from the simulate signal VI is routed directly to the DAC Assistant. The DAC Assistant 2 is used to interpret the digital input from the PIR sensor and determine if it is a high or low signal. If it is a high signal, the output of the DAC Assistant 2 will be false, in which the case structure is blank. So nothing happens at the DAC, and the LED indicator will be off. Whenever the digital input from the PIR sensor is a low, the output of the DAC will be a true, which will turn on the LED, and the case structure will then play the analog output sound through the speakers, indicating that the alarm has been triggered. The following video shows a test run of the Module 8 alarm. At this point, I'm initializing the alarm, and currently the 30-second delay timer is running. I'm watching for the 30-second delay to expire. Down here in a bowl is a piece of candy, and I'm going out to instruct my youngest son to go and find that piece of candy. He does not know that there's the PIR sensor here. Okay, so here he comes, and there's the alarm. And he's going to try again. Thinks he can sneak in.